Hello, welcome to lesson 0 of Python for Musicians. This lesson is going to be about getting up to speed and taking us from where we are now to being able to run our first Python program. What we're going to look at first is why learn to program in the first place. Then I'm going to talk a bit about Python, the tools we're going to need for the job, setting up our computer to run Python, and then just a very, very quick prerequisite refresher and some best practices that we're going to follow for the rest of the lessons. So, why learn to program in the first place? Well, for me, I found that it has unlocked parts of my brain, and I am now able to think differently, and it has unlocked a completely different way of thinking about different problems, and it has made me realize that anything is possible. In the context of music, this could mean that if you have an idea for an instrument, well, you can build it, whether it's a software instrument or it's got a bit of hardware and you want to integrate with software, like a mixed hardware software instrument, or even if it's just purely hardware. Honestly, thinking how to program has taught me, that anything is possible and you can make your own stuff. Now, there's a lot of AI hype that say, we're not going to need to learn how to program in the future because you just go into ChatGPT and ChatGPT is going to, give you a whole Python project. Now, I don't think that's necessarily true to the top extent. I think it's a very good skill to learn how to program. If anything, I'd say use the technologies that exist today to push you up rather than discourage you from learning how to program. And last but not least, it's fun. So, what is Python? Well, Python is a scripting language. What that means is that Python code is being interpreted line by line by the interpreter. So the interpreter is essentially your computer, or the part of your computer that's running the Python code. And it's running it line by line. So if it sees something that it doesn't understand, it's going to stop at that line and it's going to say, I don't understand this line, because exactly it is being read line by line. This is in contrast to C++ and some other languages where the code is compiled. What that means is that before you execute your commands or your program or whatever it is that you have scripted, there is a compiler layer that boils all the code and then translates it into machine code. But here Python is very different because it does that every single time at every single line. That does make it slow, but it has its advantages. Python also has a lot of available libraries and frameworks that do just about anything. We'll see in lessons 1 and onward that, something like NumPy, so numerical Python, and then matplotlib, and in the future we'll see librosa and soundpy and things like that. Essentially, these are bits of code that have been written by other people that take care of certain functions that you'd use in certain environments. So what do we need to run Python? Well, the first thing is an IDE, so an integrated development environment, or code editor. So this is somewhere where you can write, delete, erase, and just write code, basically. Some of my recommendations are Visual Studio Code, Z if you're on Mac OS, and PyCharm, which is very, very strong for Python. So once you have an IDE, and I do recommend that you take the time to learn different features of your IDE, you're going to need a terminal. A terminal typically it's already in your computer. On Mac OS, it's literally called terminal, and in Windows, it's called command.exe. And it's that program, we'll see it in a bit, that is just a black screen, or on Mac OS, typically a white screen with text on it, and it looks crazy scary, and it makes you feel like you're a hacker. You're gonna need that. But You can also open a terminal from within certain IDEs. So you might not necessarily have to use the separate terminal window, although I will because it looks nicer on the screen. And then finally, you're going to need a virtual environment. So what is a virtual environment and why do we need to set one up? Well, the thing is that when you're doing Python projects, you might have different projects that require different versions of both Python and the libraries and additional code that you're running. For example, if you want to try and run a Python program that was written 5 years ago, chances are that if you have newer versions of Python or newer versions of libraries that were used, you might have clashes. And your computer doesn't like having different versions of different bits of code because it goes crazy. It's like, no, which version do I run this time? Which version do I run this time? And it goes nuts, right? So a virtual environment essentially allows you to keep project-specific versions in one place so that you turn on your environment and then you run this program. Then when you're done, you turn it off. And then if you have another program or software that you want to run, then you start that virtual environment and then you do the same thing. Personally, I use Conda environments. That's what I learned to use and I find them very reliable. This is the link to go and install it. This is the command line install, but you can use any install. So I'll just go through it now with you guys. So the link there will take you to this page. It is mini Conda. It is a smaller version essentially of the entire Anaconda package. You can install it in several different ways. You can either install it with the quick command line install, or you can also just download it with like a traditional way of downloading things. But I prefer this way. I think it's much quicker and it's good practice to using your command line terminal. So this here is my command line terminal. Yours is probably going to look different. I've customized mine a bit so that it looks kind of neater and tidier than the default, but it's really not a problem. What you're going to do is, depending on your operating software, if you're on Windows, you're going to copy this code and then paste it in here and then hit enter and run. And if you're on Mac OS, then this is also what you're going to do. You're going to take this code, copy it, paste it, and then you're going to hit enter to run it. But I'm not going to do that because I already have it installed. You're going to get prompted at some point with things that look like this. So it would be yes, no. And when it says something like this, typically it expects input from you. So it will say, oh, do you want to install this? You will say yes, and then you will hit enter, and then it will install. So don't be afraid if that shows up. That's how it works. And then it says here, after installing, initialize your newly installed Miniconda. This is for macOS only. So you're going to need to install one of these, or rather run one of these commands, either the bash or the zish one. And to know which one you're going to want to do that, you go to your terminal and you type echo $0, and then this will tell you what shell you're using. In my case, it says zish, so I would take this second command here and then copy it and then paste it and then run that. So once you've installed Anaconda, you should see this base appear at the start of your command line, and that's how you know that you've successfully installed it. So the next step now is to create a Conda environment. Now, I've written this kind of cheat sheet that I'm going to put in the description on GitHub, and you can read it if you'd like to read it later. But essentially, I'm going to follow the instructions here. So you're going to type Conda to tell your computer that you're going to use the Conda software. Create to create an environment. -n, which means the name. And then it expects an environment name. So you can write whatever you like here, but I'm going to call mine Python for musicians, right? And so now it's going to do some stuff. It's going to ask me proceed, yes, no. I'm going to say yes, enter, and then very good, it's done. it says transaction done, transaction done, transaction done. And then it says to activate this environment, use conda activate Python for musicians. And thank you very much for the tip. That's exactly what we're going to do. So go ahead and copy paste and hit enter. And we are now in our Python for musicians environment. And that's what you see here. Perfect. So the last step for our environment now is to download and install a version of Python. For the rest of the lessons, I'm going to be using Python 3.10, and I encourage you to do the same if you'll be following along. And so to install Python 3.10, what you're going to do is you're going to type conda to tell your computer again that you're going to use the conda software. Install. And then we're going to say Python equals 3.10. Hit enter. And then it's going to say, oh, we have all these packages that we're going to install. Do you want to install these? And you're going to say, yes, sir. And then that should be done fairly quickly. And that's it. We have now a working Python virtual environment. Okay, so now that we have our virtual environment running and ready to be used, we can actually start writing some Python. So before we go any further, we are going to need to create a place on our computer to host our Python files. So just super quickly, I say folder and directory pretty much interchangeably. So if you hear directory and you don't know what that is, or if you hear folder and you don't know what that is, they're the same, right? So we're going to need a folder structure or a directory on our computer for our programming projects, okay? And I encourage that you have this if you haven't already. And then you can create within it a subdirectory for our Python for musicians. If you want to go the extra step and make a subdirectory for every lesson, then that's up to you. You can create within your folder that's Python for musicians, you create lesson 0, and then that's perfect. That's exactly what we want. Quick editor note here. If you've done Python before or you know the basics, then please skip straight ahead to the best practices. The upcoming basics section is not a fully functioning tutorial. It is just a checklist of things that you should know by the time we get into lesson 1. So my best recommendation is to take a very, very quick free Codecademy Python refresher just to cover the bits that you see in the basic section. Okay, so now that we have activated our Anaconda environment, we are going to want to open our project in our IDE. The way to do that in most IDEs is to go to File, Open, and then select the folder that we have created where we are going to keep our project files. And we hit Open, and here we go. So now the next step to do is to create a file in here. And you can also do that with File, New. And now we have a new file. And I'm just going to go ahead and save it immediately as basics.py. So I hit save, basics. And it's important that your Python files end in .py to tell your computer that this is a Python file. Hit save. And now we have created a basics.py file inside the lesson folder. Once that's done, we need to initialize our terminal. So if you're going to use the terminal inside your IDE, you don't have to do much. All you have to do is open your terminal, and you should see that you are already in that terminal window. So by hitting pwd, which means print working directory, you should get that we are exactly where we should be. Python for musicians, lesson 0. However, if you are going to use a separate terminal, you're going to need to navigate to that folder. And the way you do that is you type cd for change directory. And then the easiest way to get to our directory is to drag and drop our folder. So if we open Finder and we get our directory here, drag it, drop it, make sure you have a space between cd and the path of your folder, and then hit enter. and we should be there. Again, you can test it with pwd, and that's where we are. So now for the moment of truth, let's test everything and see if we have successfully installed Python on our computer. So just as a test script, we're going to explain what this means later, but just type print and then open the single quotes inside the brackets of the print. You can just copy it exactly now, and anything you like. And then I'm going to go over to my terminal. I'm going to type Python to tell my computer that we're running a Python script. And then I'm going to put the name of the script. So we called it basics.py. And now by hitting enter, you should get the output of our print statement. If you didn't get this, just make sure you saved the file before you run it. So a few things you should know is how to define a variable. So I'm going to define a variable called MIDI note of C, and I'm going to give it a value of 60. You should also know that each line in Python is interpreted separately. So now that we are on a new line, we can define another variable. I'm going to call this one frequency A, and I'm going to give it a value of 440.0. You also need to know that some bits of code are not interpreted by the interpreter. These are known as comments. And you have two types of comments: inline comments, and these are bits of text that come after a hashtag symbol. And you also have block comments. This here is a block comment, and you can tell that it's a block comment because it's inside 3 opening and closing quotes. You should know that variables represent data, and because we are writing code as humans, we want our code to be humanly readable. So it's important to name our variables according to what they represent. You should also know that there are many types of data types, but just for now, you need to know that we have integers, so whole numbers. Here are some examples. They can be negative. We have floats or floating point numbers. You can understand them as decimal numbers for now, so anything that has a point in them. Again, they can be negative. We have booleans. Booleans are essentially a value that can be either true or false. It has no other option. And then we have strings, or string of characters. And you can tell that something is a string because it's in between quotes. These things have no value. They are purely understood as a string of characters. Now let's look at how to do math in Python. Here we have an equation that says f equals 440 times 2 to the power of n minus 69 divided by 12. This is the function to get the fundamental frequency of a note given its MIDI note number. This 440 over here is the tuning of the note A. And this makes sense because the MIDI note 69 is A above middle C on a piano keyboard. Say we want to calculate the frequency of the note middle C on our keyboard. What we'll want to do is create a variable called frequency of C. And then we're going to want to type out this equation with the number here to be 60 because that's middle C. So we'll type out 440 times in Python is the star. Then we're going to say 2 to the power of is double star. And then we're going to put the rest of our code in brackets. We're going to put an extra bracket so that we can tell basically that everything inside the first bracket is in the exponent. We're going to say n minus 69 and then here divided by 12. Now, we don't have n. We have previously defined n to be MIDI note C. So I'm just going to copy that and toss it in. And this 440 over here, as I said, is the frequency of A. And we have already defined that as well. So I'm going to take it from up here and paste it in here. And let's print out the frequency of C. So I'm going to say print frequency of C, save, and then I'm going to run it. Python basics, enter. And here we have 261.625 blah, blah, blah hertz. You should also know how to define functions. So let's define a function that does this equation for us. We start our function definition by saying def for define. Then we're going to call our function MIDI to frequency, and then we open and close the brackets. Inside the brackets, we're going to put our variable. So what is it that we expect to take in? In our case, we're going to say we want the MIDI note number. And then we're going to end our definition statement with a colon. Now, to tell Python that the rest of the code is going to be inside the function, you need to indent your code by 2 or 4 spaces. It's important to be consistent. Personal preference is to use 4. So we're going to now say that the frequency is equal to 440 times 2 to the power of MIDI note. And note that I'm saying MIDI note, which is the same value as what's in here, because this is what we want to use, not a previously defined variable, minus 69 divided by 12. So now this variable here, frequency, is forever stuck inside our function definition. We need to get it out, and the way to get it out is with the return statement. So we say return frequency. And now when we call our function, it is going to give us the value of frequency that we have calculated based on the MIDI note. So let's quickly test it again. I'm going to delete this bit of code here, and we're going to try and replicate it using our function. I'm going to say frequency of C is equal to MIDI to frequency, and then the MIDI note number of C, as we have already defined it, is MIDI note C. And then to see our result in the terminal, I'm going to say print frequency C, save, and then I'm going to run our code again, python basics.py, and here we go. We have received the same value that we got before. Let's have a quick look at Booleans. Booleans are values that are either true or false. A good way to get these Booleans is to use comparisons, statements that return Booleans, either true or false. So let's create a new variable, and we're going to call this MIDI note to test. And we're going to, for now, give it a value of 36. Let's compare this MIDI note to test value here to middle C. We're going to go and say print MIDI note to test is smaller than MIDI note C. And if I save that and run that, we should see that our statement is true. If we said MIDI note to test is greater than MIDI note C, and I save this, I expect the output to be false. Another comparison operator that we can use is to check for equality. So let's say MIDI note to test is also 60, and I want to see whether the MIDI note to test is equal to MIDI note C. You can do that with double equals. And the reason you put double equals is because remember that the single equals, as we see it here, is the symbol to assign a variable. If I save that and run this, we should hopefully get a true. Very good. And finally, with both greater than and equal to than, we can also have greater or equal to. The way you get greater or equal to is you put a greater sign followed with an equal, but without the space. Now my interpreter just makes it look nicer, but it's going to look normally like a greater equal sign. And now, because it is technically true that 60 is greater or equal to 60, we should still get true. So why are Booleans useful? Well, Booleans can be used to dictate the flow of your algorithm. For example, instead of printing the result of this, what if we put it inside an if statement? So we say if this, then print, and we're going to say MIDI note is middle C or above. Let's go ahead and say else, which is going to execute if our initial condition is not true. Print MIDI note is below middle C. Our MIDI node to test is still 60, so we hope to see this print statement. MIDI node is middle C or above. And if it wasn't 60, if it was 50, then we should get MIDI node is below middle C. Now say we wanted to separate this greater or equal to and have 3 different tiers. We can say if MIDI node to test is greater than middle C, then we're going to print is above middle C. Then we're going to say else, and then inside the else we're going to have another if statement. So if MIDI node to test is equal to, again, here's the double equals, is equal to MIDI node C, and we put another colon at the end, we're going to have another print statement. Print MIDI node is middle C. And then finally, we're going to have that else statement at the end. And it's important that the else statements always come at the same level of their respective ifs. And that any text that you want to be happening after those statements need to be indented by another for. So what we've done here is we've said, if our note is above middle C, print note is above middle C. Otherwise, new check, MIDI note is equal to middle C, print MIDI note is equal to middle C. And if that also fails, then print MIDI note is below middle C. Now, this is very cumbersome and is very, very bad writing. The reason is we have an else if. An else if can be shortened to elif. So instead of here having 2 different statements, I'm just going to go and say elif. And then I'm going to remove this if here. And I'm going to put this all after the elif statement and bring this back. And then both of these, I'm going to bring them back. And so what we have done here is exactly the same logic, except that it looks neater. So if the note is above middle C, we print middle note is above middle C. Else, so if not, if again, MIDI note is equal to middle C, then we print that. And then finally, if neither of these statements are true, we're going to print MIDI note is below middle C. So again, testing with 50, we should hope to see MIDI note is below middle C. If we tested with 60, we should hope to get that it is equal to middle C. And if we have something that's above this, say 62, we should hopefully get MIDI note is above middle C. Let's talk about best practices now. So I'm just going to go quickly and clean this script a bit. I'm going to paste this instead, and then I'm going to take these, paste them over here, and let's go through these one by one. So, key points of best practices. Name your variables using snake case. This is an example of snake case. It's where all the letters are lowercase and the spaces between words are used as underscores. This is standard in Python, is not obligatory by any means, but is just how the Python community has agreed to write their variables. The next best practice is to wrap your runnable code inside an if name main. What that means is that all our code that we actually want to run, things that are directly responsible for the output of our script, we want that to be inside a statement that's exactly like this. Now, you don't have to understand what this necessarily means just yet, but this is what we expect. Okay, so this is just another conditional statement. If name is equal to main, then run what's inside here. So in our case, the code that we are running is this. MIDI note these things, cut them, put them here, and then there is this, put this here, and then all of this, put this here. Now we can go the extra mile and define a separate main function. And this is in line with what you'd see in C++. You'd see here, define main. All of this would go inside that main function. And then here we'd have main. Another best practice is to use type annotation to increase both readability, but also so that you can get used to languages that require this kind of thing. Again, C++ is an example, but it also helps you and your code understand better what you expect from certain functions. For example, here we've defined MIDI to frequency. We expect MIDI note to be an integer. So the way you tell your Python code that you expect it to be an integer is just after that variable, you're going to go colon space int. And then to say that what you're returning is a float, between the closing parentheses of the function and the colon, you're going to go dash greater than, which looks a bit like an arrow, and then you're going to type here float in small letters. Now I'm quickly going to wrap this statement here inside the function. So I created here the function say MIDI location, which is going to take in a MIDI note and then is going to do exactly what we had before. The MIDI note that we expect is also an integer, but there is no return statement here. So what we're going to do is put the arrow and say none. Here none has a big N. Another best practice we have is to be consistent with our indentation and format our code nicely. So here, for example, we have been very consistent with our indentation, but we haven't really been consistent with the way we write code. Here we have 440 times 2, and there are spaces in between these operators. And here we don't have spaces. So either commit to the spaces or don't, but don't do anything in between. It's just ugly. What you can also do is leave spaces. It's always nice to have some space in your code. And then the last best practice we're going to follow is comment where needed, but don't overdo. For example, this function is pretty straightforwardly named. MIDI to frequency takes a MIDI note and then returns a float. If you're confident with being able to understand this, then you probably don't need to comment it. But for example, you could put a comment for yourself to say where you got this formula from. So in my case, I got this equation from a website and I went and pasted the website URL over here. So these have been the basics that we need to know and the best practices that we'll be following. If all of this is super new to you, I encourage you to find some very introductory Python course, either on YouTube or Codecademy, just to get used to how you write code. Anything past this, we're going to see together. So make sure you get to this level and then come back for lesson 1 and we'll take it from there. The next lesson is going to be looking at lists, arrays, and sine waves. So I'll see you then.